Well, class, here we are again, one more time. I had planned on being with you tomorrow. I was going to send an email and try to do a 30 to 45 minute class with you and then with algebra and just have Courtney do chemistry for me. But I went out today, and my first time out since Christmas, except being in the hospital. I went out and taught my Algebra 2 class for an hour, and I am just exhausted. So because of that, I'm a little bit leery about trying to go 2 days in a row. I need to get my strength back up a little bit. But next week, there shouldn't be any reason why I can't be with you. So I'm looking forward to that. So as far as what we'll do today, I'm going to go over the handouts I gave you on the proofs, give you all the answers. I know some of you were confused, especially on the second page. We'll work through that. Your test will not have anything like on the second page. It'll strictly be your logic as far as your contrapositive, inverse, biconditional statements, conditional statements, hypothesis, conclusion, all those type of things, along with about 3 or 4 proofs that I actually give you some choices on the bottom to choose from to fill in, so you can use those words to help you complete those proofs. And so the test should not be hard. I'm going to go ahead and send the test, and you can take it home. If you're working through it and you feel really confused, then I'll give you an extension. It'll just be in 2 weeks to get it done. If you understand it, I would go ahead and take it, because this will be a light week of homework, and it's good to take your test when it's a light week. But if you're having trouble with proof still, I don't want you to take the test and not do well. So, I want you to make sure you feel comfortable with the test. But that is what is involved. If you did well on these sheets, and you did well on what I gave you that Courtney went over last week, review biconditional statements, those would start with if and only if, so IFF is the abbreviation for that. You always start that with biconditional statements. If you feel comfortable with all of that, then you'll be ready for the test, okay? So I'm going to go ahead and go over the worksheets that you did for homework. And the first one, you had so if you'll pull those out, I'll give you a minute to pull those out. And the first one, I'm going to go ahead and draw the shape. And of course, not the best shape. I'm not the artist. But we have N, M, O, P. And it told us our givens, and it says that our givens were line segment MN is congruent to line segment PO, and that MO is congruent to PN. So let's go ahead and mark that MN to PO, and then it said that MO to NP or PN, okay? And so that's how it would be marked. Now I see I've got these 2 congruent sides. I see that I've got these 2 congruent sides. I don't see that there's any way that I know that I'd have a congruent angle. And I have this line right here, which is a shared line. So that would actually be my 3rd congruent side. So your proof, you have your first given, and your reason is given. Your second given, your reason is given. The next part is ON is congruent to ON. That is called the reflexive property, shared line, but I want you to learn reflexive property, and it's by side, because we're marking sides. There are no angles. Side, side, side. There are 3 sides. So that would be your answer for that one, okay? On the next one, kind of have a bow tie type looking thing, shape, and we have, and of course this is not, according to my drawing, it's not, you don't see congruence because it's a little bit off, but we're going to go with what it tells us. And on this one, it wants you to go ahead and write a paragraph to show the proof. So you're not going to set up your statement and reasons on this one. But it does give us 2 givens. It tells us that AC is congruent to DC, so let's go ahead and mark that. And it also tells us that BC is congruent to CE, okay? Now, I have no way of knowing if these 2 sides are congruent, but I see something that I know would be congruent, because I see that these 2 angles are vertical angles, so I know that they have to be congruent. So I'm going to go ahead and mark that, okay? So I can go ahead and determine that I've got a side, an angle, and a side, okay? Or side, angle, side. So I know it's going to be proven by side, angle, side. So your paragraph would say something to the, in some way like, I am trying to prove that angle ABC and DCE are congruent by side angle side. I was given the information that AC is congruent to DC, that BC, line segment BC is congruent to CE, and I know by the definition of vertical angles that angle ACA or BCA and DCE are congruent because they're vertical angles. Therefore, my triangles are both congruent. So something along that line, not word for word, but starting with side angle side, telling the givens, and then what else you added to make that congruent. So a short little paragraph. Okay. The next one you get to do statement and reason all by yourself. And if you draw the shape, you're going to prove that triangle ABC is congruent to CBD. And I actually think that on this particular one, if you draw two triangles, on this particular one, you might have had a little bit of difficulty. I have the answers here in front of me, but you might have had some difficulty because there was not a drawing. And this might have been the one that I got a question about. So let me just make sure that the drawing's not on another page that goes with it, and I don't think that it is. So I don't know. You can skip that one. I'll go ahead and tell you the answers that I would have had so that you can see, but without a drawing, you don't know whether these triangles are side by side or whether they're attached. So I'm going to get another marker here. The blue one's kind of getting dry and getting on my nerves. So I'm going to go ahead and tell you that you write your two givens down, and these would have been triangles that would have been connected a lot like number one. And so it would have been reflexive property, it would have been side, side, side. So this would have been one that was almost exactly like number one, but they did not draw that for you to look at. So you really didn't have enough information. Okay, on the next page, page 2, two angles whose measures have a sum of 180. This goes back for a while ago. Those are actually supplementary angles. Two angles whose measure have a sum of 90. They are complementary angles. And number 3, blank angles are two coplanar angles with a common side, a common vertex, and no common interior points. So they share a common side and they share a common vertex. This would be adjacent. Now this is where some of you begin to have a little difficulty, and there was actually a misprint on this particular one, so if you got stuck on this one, what they should have had for you, they should have told you that angle A equals 2x minus 5, and then they should have had measure of angle B equals, this is where the misprint was, x plus 35, and I think that they had 5 down, or 15 I think is what they had. And that makes a big difference because with 15 it's very difficult. You get a decimal answer. So let's talk about what it's telling us. It tells us that angle A and B are complementary. What does complementary mean? It means that they add up to 90 degrees. So all that you would do is take angle A, 2x minus 5 plus x plus 35 equals 90 degrees because it told us they're complementary. Next thing you're going to do is combine the things that match. You have 2x plus x is 3x, and negative 5 and 35, or 35 minus 5, is 30 equals 90. Now the next step is to go ahead and subtract the 30 on this side, and we get 60. 3x is 60, so we're able to solve for x. 3 goes into 60 20 times. Now, we know that 20 is the answer for x, but we want to find the measure of angle A. So we would go and we put 20 here. 20 times 2 would be 40, and 40 minus 5 would be 35. So you just plug it in, you just substitute it. This one, 20 plus 35 would be 55. Now I went ahead and worked that one. Again, if you had 15, you would have had trouble because you would have got a decimal answer and it made it very difficult to get something that added up exactly to a 90-degree angle. So that was a misprint. It should have been 35. And I apologize for not catching that earlier. We did these last year, and I think we did that and I just forgot to make a note of it. So the next one, number 5. A supplement of an angle is 4 times the complement of the angle. Find the measure of the angle, then find the measure of its complement and supplement. Well, first thing I see the word supplement, so I'm going to write 180 degrees. And it tells us we're going to take away the angle itself. So the angle is x Okay, so I'm going to deal with finding the angle in a little bit. So we're going to take away the angle for right now. And we know that the supplement of that angle, 180 degrees of the angle, is 4 times the complement. So that's 4 times 90. And again, we're going to take away the angle for a minute, okay? Now, I can go ahead and clear my parentheses over here. So 4 times 90 is 360. And then I'm going to go ahead and 4 times x is minus 4x. And just copy this side. Now I want to transpose, get my x's on one side of the bridge and my numbers on the other. I'm going to go ahead and bring this over here so that it will end up being positive, because make this a positive 4x. And I'm going to bring the 180 over here. Okay, so I'm going to go ahead and subtract here. And I get 180, and I get 3x here, because negative x plus 4x is 3x. Okay? So 3 goes into 180 60 times, so x is 60. So that's the measure thereof. My angle is 60, okay? The complement, what do I need to add to 60 to get 90? Well, the complement would be 30, because if I add 30 to 60, I get 90. My supplement, what do I need to add to 60 to have 180? Well, the supplement would be 120, okay? So you solve for your angle. We took away the angle here because we're just talking about the supplement and the complement the angle. So we're taking away the angle, and then we end up solving for the angle. And then when you get your answer, you need to find out what the difference is. But for the complement, 90 minus 60 would be 30. The supplement would be 180, because supplementary is always 180. 180 minus 60 is 120. And so that's how you do that one. Okay? I'll give you a minute to make sure that you have that copied, because as I'm talking and you're copying, it's sometimes hard to understand what I'm saying. Okay? Keeping that in mind, in this one is a little bit different. The measure of a complement of an angle is 3 more than twice the measure of the angle. All right? Find the measure of the angle and its complement. Okay? So So I know that 2 angles here, the measure of a complement of an angle is more than twice the measure of an angle. Find the measure of its angle and its complement. Okay, so in this one we're actually going to be adding, I'm going to make an angle A. Okay, and I'm going to make it plus the 2 times the A plus 3, because it's 3 more than 2 times. And it says that the measure of the complement of the angle. So all of this equals 90 degrees. Now at the top, it told us the supplement of the angle was 4 times the complement of the angle, so we were putting them equal to each other. This one says the measure of the complement of the angle is 3 more than twice the measure of the angle, so all of this adds up to 90, okay? Now I have A plus 2A is 3A plus 3 equals 90. I'm going to subtract my 3 to get everything to the same side, opposite side of the bridges, I'm sorry. And I get 87, and 3A equals, okay? 3A equals 87, so 3 goes into 87 29 times when you divide that. So I know that the measure of my angle is 29. This one, it doesn't ask us to find the supplement, it just asks us to find the complement, find the measure of the angle and the complement. So this would be 90 minus 29, which the complement would be 61. So you can copy that. Okay? Okay. The next one, number 7. A supplement of an angle is 4 times the measure of an angle. Okay? Find the measure of the angle. So anytime that you see is, you should think of there being like an equal sign here. So I have a supplement of an angle is 4 times. So here's angle plus 4 times the angle equals 180. Okay? Find the measure of the angle. All right, so in this one, let's go ahead and combine these two. 5A equals 180, not 58. 5A equals 180. And In this situation, A, if you divide that, you'll get 36. So we know that the angle is 36, and it doesn't ask us anything else, okay? That's all it asks us to solve for is the angle, okay? All right, then the last question is, on that page, is vertical angles are always, it gave you a choice, vertical angles are always congruent, okay? Because we know that complementary adds up to 90 and vertical angles don't do that, and they don't add up to 180, which is supplementary. On page 9, I'm going to go ahead and solve this one with you, and then you should be able to do the other ones. I see that I've got two vertical angles. Vertical angles are equal to each other. So 2x plus 3 is equal to 35. Then we just move that over there. I get 32. 2x equals 32. I'm sorry. It's just not 35. It's 33. That makes a big difference. 2x equals 30. X will equal 15. Okay? Same thing with number 10. You said 3x minus 2 equals 5x minus 8. Your answer will be 3. On the next one, you have a 35-degree angle, and you have a 90-degree angle, and you have x. That's the angle addition postulate. And so you're going to add the 35 plus the 90 plus the x, and all of that will add up to 180. And the answer will be 55. On number 12, you've got vertical angles again, so they're equal to each other. X plus 2 equals 46. And your answer, excuse me, I'm sorry, y'all. Your answer will be 44. Okay. All right. Moving right along. Then we have some proofs here that you had to get to do. And I see in here that my given includes a midpoint. It says the midpoint of AG and of NR, that M is the midpoint. And we need to prove that these two triangles are congruent. So I'm going to go ahead and start with what's given. And they marked some vertical angles. They didn't tell you the word given, but they marked it for you. So that's what I'm going to start with. Vertical 1 is congruent to angle 2 because they're vertical angles. Then it says M is the midpoint of AG, and that was one of our givens. Then it says that AM is congruent to GM. Now remember, if I saw midpoint in the given, then I know I'm going to have definition of midpoint somewhere, so that's going to be definition of midpoint. Then it says M is the midpoint of NR, that's also a given. And NM is congruent to RM, well again, we have another definition of midpoint. And if you mark all of that, you see that you've got two sides congruent and an angle in the middle, so that would be side, angle, side. Okay, so let me go back and give you the answers. Vertical angle, given, definition of midpoint, given, definition of midpoint, and side, angle, side. And the next one, you write a two-column proof again, and you have to do this on your own. The given is AE is congruent to BD, not congruent, I'm sorry. AE, line segment AE and line segment BD bisect each other. I see the word bisect, so I'm probably going to have definition of bisector in there. And I want to prove that the two triangles are congruent, so let's start with the given. AE bisects BD, that's given. I can then say that AC is congruent to EC because the definition of bisector. And I'm going to go ahead and draw this and show this to you so we can talk about it. Okay, so this is labeled A, B, C, D, and E. And the givens, it told me that that A, wait a minute, is it labeled wrong? It is. That might have been a AE and BD. If this confused you, I'm sorry, because this is labeled wrong. I'm just going to flip this here. Show you how it works. A, E, and B, D bisect each other. So I have A, E bisects B, D. That's my given. And I would say that AC and E is congruent to EC. That would be my definition of bisect. Then the next given would be BC is congruent to DC. So the congruence were the given was just opposite from the drawing. So that's another given. And then it tells us that then BC and DE are congruent to each other, and that is the definition of bisect. The next thing that I see, now I've got two line segments. I know that These two are congruent. These two, I need one more piece of information to see that these triangles are congruent. And I don't have any way of knowing if these sides are congruent, but I know that these angles are because of the definition of vertical angle. So I would say that angle BCA is congruent to ECD by vertical angle. And then I know that I have side, angle, side. So I'm sorry if that was confusing. I didn't notice that they had done the drawing wrong, but they did, and that does make a difference. Okay? All right. The next one almost looks like a kite. Okay. And we've got a split in the triangles right there. Well, not the best drawing, but you get the idea. And we've got N, M, hopefully the letters are in the right place now, and J. And they told us that this is here. So our givens are that NK, line 7 NK, bisects angle JNM. Okay, so this comes right through and almost cuts it in half. Okay, if it kept going, it would keep going. It would totally be a bisect. Okay, anytime that you see bisect, you know that the next thing would be that angle JNK and MNK, these two angles are congruent by definition of bisector. So you have that, and the given is the bisects as your first one. The second one's going to be the definition of bisector. The next one that I notice is I have these two marked for me. I need one more piece of information. I can't determine that any other angles are congruent or any other sides except this right here because this is a shared line, or it would be reflexive property. So you go ahead and you put your other given in, and then the third one would be your next given, and then you have the NK is congruent to NK, and that's your reflexive property. So let's go ahead and mark it, and that would be the triangles are congruent by side, side, side. Okay? All right. No. Not side, side, side. Because it told us the angle, one of our givens was the angle was congruent, that we have congruent. So yeah, number 2, when we said definition of bisector, it would tell us that J and K is congruent here, okay? So it's actually going to be side, angle, side. I apologize. Maybe it's because I'm short of oxygen a little bit. I don't know, I'm always ditzy, so I don't know that I can use that as an excuse. Okay. Next page, complete the 2-column proofs. I'm going to go ahead and just give you the statements and the reason. So the first statement is our given of BD bisects angle ABC. That's your given. The next thing that I want to see is that angle 1 is congruent to angle 2. That's a definition of bisector because we had bisect in there. Be ready to have a definition of bisector. Angle 1 is congruent to angle 4 because they're vertical angles, and angle 2 is congruent to angle 4. Now this is one that was back in your book. This would be substitution, okay? You will not have anything with substitution on your test, but you'll want to look that back up and understand that. Number 14, given angle 2 is supplementary to angle 3, so that is the first thing I put in my statement, and the reason is given. And then I'm going to go ahead and look at, it tells me that 2 is supplementary to angle 3, means they're going to add up to 180. So I want to find that the measure of angle 1 plus the measure of angle 2 equals 180, because I would be able to know the measure of angle 2 if I knew the measure of angle 1. That's a linear pair. And then I would say that angle 2 is supplementary to angle 1. Now, up here in our given, it was supplementary, so this would be definition of supplementary, okay? And the last one, number 4, angle 1 is congruent to angle 3. And this would be actually writing out the definition. If 2 angles are supplementary to the same angle, then they are congruent. So that takes us back to the, whoops, no it doesn't, I got one more page. And I think that I had some of these filled in for you. Completed 2-column proof on number 12. You have DE. Line segment DE is parallel to BC. That's one of the givens, so let's write that down. Your next given is angle 1 is congruent to angle 3, so we write given. Angle 1 is congruent to angle 2. So that would be corresponding angles there, okay? And then angle 2 is congruent to angle 3, would be substitution, okay? The last one, A is parallel to B, so you would put that as your given. A is parallel to B, given. Angle 1 is congruent to angle 2. Those are corresponding angles. They're sitting on the top piece of bread and the top of the bottom piece of bread. Angle 2 is congruent to angle 3. Those are vertical angles. And the last one I filled in for you, angle 1 is congruent to angle 3. That's a transitive property of congruence. If two segments or angles are each congruent to a third angle or segment, then they are congruent to each other. That is not something that you need to know for the test. Also, whenever you do like the ACT or the SAT, you don't do actual proofs. So one of the reasons for that is in each curriculum, the theorems and postulates can be named something different, with the exception of side, angle, hypotenuse, leg, all of those, triangle sum theorem, angle addition postulate, those stay the same throughout, but there's some of these, like the substitution, the transitive property, some of them are, they can be different in a different curriculum. So you might see something like with side, because that's kind of universal, but you would not be doing a completed proof. Okay? All right, so that brings us to the beginning. That's your answers for that page. I hope, if you have any questions, put a star on those. If not, you can go ahead and turn those into Courtney and make sure your name's on them so that you have credit for doing that. The next thing that I'm going to have you do is I'm going to send home a sheet. It's called a bonus work, but this will not be bonus work. I will actually grade this. You will not be penalized for any that you get wrong. This covers things from the very beginning of the book till now. It's not a test, but and I don't care if you look back and kind of refresh yourself on how to do them. It's fine. You can look through your book, and you can go ahead and complete the answers. When I get those from you next week, you will only get credit for the ones that you get right. Now, if you don't do it, then you'll get a 0, and it will count against you because this is your homework, part of your homework. If you do it and you only get 3 right, each one will be worth, I haven't decided whether a point or 2 points. The benefit of that is as I've got some of your tests to give back to you that I had for a while, I'm kind of looking back over the grade book, and even though I dropped the lowest test and the lowest quiz, some of you, maybe you got a 75 or something on the test. And if I were able to give you this sheet and say you got 10 extra points, that would pull you up to an 85. And right now, I think everybody could use any extra points. So I do want you to do that. It'll refresh your memory on how to do all of these things. If there's anything on the sheets, I'll double check it. If there's anything on there, I will put a little note that you don't have to do some certain numbers. If it's something that we haven't covered yet, you're welcome to try it. Again, you're not penalized, so you can try it, and if it's wrong, it won't hurt you. You just get credit for what you get right. So I think we've covered everything on there so far. The next thing that you want to make sure is that you can go ahead and take your test if you feel like you're ready to do proofs. Again, it will not be as hard as the homework sheet, and you will not have any like from the second page. It will be a lot of logic, so review all that. Your definitions, remember that biconditional statements start with IFF, for if and only if, when you write those out. And then you'll need to make sure that you understand the difference between inverse and contrapositive and be able to provide an example if it's false, a specific example, so you'll need to know how to do that. And then, like I said, I think there's 3 proofs, and I give you the answers to choose from to fill in the blanks. So it's really not a hard test. It's not to trip you up. It's to make sure that you understand the concept of what we've been doing. I'll send home those other sheets that are labeled bonus sheet. And then I'm going to go ahead and I'll be sending you the first 3 lessons from the new book. So you'll get some notebooks. And I haven't been able to get out to Get Office Depot to copy the whole books, but I did copy the first 3 lessons. We probably will not have time to get to the first 3 lessons since I'm giving you the bonus work too. I will probably just go ahead and do the first 2 lessons with you, and then the 3rd lesson will be added on to next week. The first 3 lessons do involve trigonometry. Very, very simple. It's very basic, kind of an intro to trigonometry. So we're going to go ahead and jump into that now. So when you're dealing with trigonometry, you're dealing with terms sine, cosine, and tangent. Okay? So I want you to go ahead and open up those notebooks that I gave you, and in the pocket I went ahead and included the first 3 lessons. I also had included behind it the answer key for you so that you can check yourself. One of the things that will help you with trigonometry is to remember these words. So, ka, to. Almost sounds like staccato. So-ka-to. Okay? What that tells me is the S is for sine here, and this is for opposite over hypotenuse. I'm gonna explain that, but let's go ahead and write it. Opposite over. Now you should remember what the hypotenuse is. It's the longest side of a right triangle. Okay? Ka, that C is for cosine, and the A is for adjacent over hypotenuse. Okay? And then you have to, the T for tangent, and this is opposite, O is for opposite, over adjacent. So you want to go ahead and write that down or highlight that somewhere, because this is really going to help you understand. I'm going to explain what this means here in just a second. Okay? So let's go ahead, and I'm going to just write this kind of smaller. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Just kind of keep that there so that you can look at it as we do these, okay? So let's go ahead and talk about what we mean when we're talking about opposite over adjacent and all of that. So we have a right triangle here, and inside the triangle I have a degree that I'm looking for, okay? A lot of times when you're doing your work, they'll actually tell you what that degree is. We know that this is the hypotenuse, because it's the longest side, okay? And so you want to keep in mind, I'm trying to figure out what side is the opposite and what is adjacent. Well, here's the angle in this one that we're looking for. So this is actually sitting on the lines, we call that's adjacent to. It's not always the bottom, because I'm going to flip it in a minute and show you. And then if you were sitting here in this corner and you were looking outward, opposite of you, or opposite of this angle, is opposite, okay? Now, so that's how you know hypotenuse, adjacent, opposite. If you flip this and put this here, hypotenuse is always going to be the longest side. If you put this here, then the X is sitting on this line, so that'd be adjacent. And it's looking out opposite, looking out across the field, and there it is, so that would be your opposite, okay? So that's how you would do that. That's how you would, your reference angle, and that's how you would label those. So on page 221, they go ahead and they show that to you. They tell you opposite over hypotenuse. You're looking at that angle there. And then they show you that cosine is adjacent over hypotenuse and tangent is opposite over adjacent. Now, I don't know that I'll be giving you a quiz. I may be giving you a quiz next week, so be ready to know so-ka-to and be able to write sine x equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now, if you remembered so-ka-to, that will help you because the abbreviations are there for you. So if you just remember that, so-ka-to, you should be able to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's talk about what we would do. What are all these numbers? What do they mean? So these are for solving for missing sides of right triangles. Okay, so we're actually solving for sides. In the next lesson, we'll be solving for the angles. So in this particular one, if I wanted to calculate the value of sine or sin 34, on most calculators, you're going to enter the button that says sin on it, teaching you to sin in geometry. So you sin, and then you're going to push 3, 4 for 34 degrees and push equal sign. Now my calculator and some of the calculators you have to do 34 sin. And this is on an Apple calculator here. I'm going to just go back to the basic, okay? And I believe that I have to enter in sine. Nope, I don't. I have to do 34 sine. And it gives me my answer, okay? So on that particular one, my calculator, I have to do the 34 degrees and then push the sine button, the sin button, okay? So then if we were to do tangent, now it does say if it says rad or grad, you need to change it to degree on your calculator, okay? And if you don't know how to do that, consult a manual or ask somebody how to do that. And here are some more to practice. So if I did tan 51 knowing my calculator, I have to do 51 tangent, and it gives me that number, okay? If I did cosine 73, I do 73, and I hit the cosine button. One more, sine 18, 18, sine. Most of the time you're going to go ahead and write out to about the hundredths place for your answer. Make sure, yeah, usually it's about the hundredths place that you're going to write to, your 2 decimal places. Okay, so let's go ahead and talk about how we use this to solve things. All right, I'm going to draw this triangle here. Okay, and I have well, let's not do that yet. Let's just put 47 degrees. 47 degrees, here's our example. And then we have x, and we have 12. So we know something about this side, we know something about this side. We know nothing about this side. Let's go ahead and label this. This is my hypotenuse. 47 is looking out to the opposite, or just label it O for opposite. And the line it's sitting on is adjacent. So I know something about opposite and hypotenuse. And the one that deals with opposite and hypotenuse is sine. Okay? So I know I'm going to be dealing with sine. And sine 47 degrees, where did I get the 47 degrees? Right there. So then I can go ahead and solve 47 sine. And on this particular, let me see, make sure I'm getting the right. I have to go ahead and round my decimal up. But let's see here, that would, for 47, I get that. But then they went ahead and let's see here, now plug in the numbers. Oh, just sine 47, I got my number. So we know something about opposite and hypotenuse. Let's plug this into here. Do I know anything about opposite? No, I know it's just x. Do I know anything about my hypotenuse? Yes, it's just 12. So then I put sine 47 equals x over 12. Now I don't like fractions, so to get rid of the fraction, I'm going to multiply both sides by 12. Okay? This cancels out, and this is sine 47 times 12 equals x. So I'm going to go ahead and enter that in. I'm going to do 47 sine. Make sure that you just do the S-I-N, not the S-I-N-H, okay? And then I'm going to multiply it by 12. And I get 8.776. We're going to round it to the second decimal place. So if I'm rounding it to the second decimal place, I look at the second number behind the decimal and then look at the one beside it. And that's, if I have 8.776, 6 is bigger than 5, so it goes up to 8.78, okay? Now I want you to know whenever you're dealing with this is always an approximate. It's not equal to, it's an approximate, okay? So let's go back through and talk through how we did this. X is opposite, so we plug that in with opposite. 12 is hypotenuse. I get rid of my fraction. I multiply sine 47 by 12. I push 47, the send button for sine, and then multiply that by 12, and then I round it to the second decimal place. Okay? All right, so that's how we do that. So let's go ahead and do a couple of these together. And I will probably stop after this first lesson, actually, and not do the second lesson, because it's getting a little bit harder for me to breathe, and I've got a couple more videos to do and take breaks in between. So here's another one. On this one, I've got 63 degrees. I know that this is my hypotenuse, so I'm going to go ahead and label it. And this one is my adjacent, because it's the 63 sitting on it, and this is my opposite. And this is 17. I know something about adjacent and hypotenuse. I know nothing about the opposite. See, because the hypotenuse is x, and the adjacent is 17. That's what I'm talking about when I say I know something about them. The one that has adjacent and hypotenuse is cosine. So this would be cosine 63 degrees equals, and remember this is adjacent over hypotenuse. Again, I don't like fractions, so let's get rid of it by multiplying by the denominator on both sides. That gets rid of that. And now I have cosine 63 times x equals 17. Okay? So what I'm going to go ahead and do is I'm going to go ahead and do my cosine 63. So 63, push my cosine button. Rounding it to the decimal place, I get 4.54. Okay? x equals 17. Okay? Now, in this particular, make sure that they got the right, 4.5. They actually did an extra decimal place. I don't know why they went 4 places over, but they did. And so whenever I see something with x here, x wants to be by itself. So I want to get rid of this, and I'm going to divide it to get rid of it. So that means I got to divide this side. So now I do 17 divided by 0.4540. And so my approximate answer is x is approximately 37.44. Okay? So whether you put the 0 on or not, it wouldn't matter with your answer. Okay? All right, so let's go back into and talk to this one. This had a little bit different. Here's my angle, my reference angle. Here's my hypotenuse. And my hypotenuse is labeled as x, so I know something about it. Here's my adjacent. There's my opposite. 17 is my adjacent. The one that involves the adjacent and the hypotenuse is ka. So I put my adjacent over the hypotenuse, 17 over x. Get rid of the fraction by multiplying both sides by x. Cosine 63 times x is 17. Go ahead and enter 63 cosine, or if your calculator's cosine 63, that's fine. But mine is 63 cosine, and then I get this as my answer multiplied by the x equals 17. X wants to be alone. To get rid of it, this is multiplication, so we do the opposite. We divide. We divide 17 by 0.4540. We get an approximate of 37.44. Okay? All right, let's go ahead and do the other one, and then I'll turn you loose to do the others for homework. So the next one, I kind of drew it at a different angle, but it's still a right triangle. Well, the other one they did too, and I didn't fix it there. Whoa. One of the things that's helpful is they usually mark them a right angle. Okay, so on this particular one, actually that's not a very good drawing here. Bring this out a little bit better there. Okay, here is my hypotenuse. Here is my reference angle. Opposite my reference angle is right there, and this is my adjacent. And it says in this one that my opposite is x, and my hypotenuse is 27. So on this one, again, I deal with opposite and hypotenuse. I'm dealing with sine. So I'm going to say sine 39 degrees for my reference angle equals opposite, which is x, over hypotenuse, which is 27. Let's get rid of the fraction by multiplying both sides by 27. Now I have sine 39 times 27 equals x. So again, on my calculator, I do 39 sine, and then I multiply that by 27, and I get 16.991. So I get 16.99, and that is the approximate answer for x. All right, so you can go back and look at how to do these. We did not do a tangent, but you'll do it the same way. It's great when you don't have to do any division. You just multiply and figure out what it is. But sometimes you have to do some division to get rid of the fraction. So anyway, there we go. We do have to do multiplication up here to get rid of that fraction. But like the last one we did, we had to get rid of the fraction at this point too. So if you have any questions, put a star by the ones you have questions for. And I want you to add to your homework going through page 226. So you have several pages that I gave you that you will not be doing. The next lesson will start with solving for missing angles. So this would be an x. Instead of this one, we're solving for the missing side. The next session will be solving for the different angle. And we'll do that next week together. I don't want to go ahead and do more. One reason I can't talk anymore, but I'm also going to be sending you home with your test, and I'm going to send you home, it's about 7 or 8 pages of that bonus work that you can do, so you can split that up, and then doing the 3 or 4 pages that come with, I think it's 4 pages, 1, 2, 3, 4 pages. On the first page of your homework in here in 223, you're just going to be labeling opposite, hypotenuse, and adjacent. You don't have to do any solving. And then you start solving, doing the math with your calculator on 224, 225, and 226. And you can stop there before solving of missing angles. Okay? So again, next week, I should be stronger. This was my first day out, except going to the hospital. And I thought I wouldn't be as worn out, but I'm real tickly in my lungs, and I'm real tired. So I need to listen to my body and not try to push it for a while tomorrow. So next week I will see you in class, barring an emergency. Please pray for Wade. He has surgery on Monday. I appreciate your prayers, and I'll look forward to seeing you next week. Again, if you have any questions on this, don't sit at home trying to figure out. If you have any questions, please send me an email. I know that I got a couple questions on the homework, and the ones that were asked were a little bit too difficult to explain in email, so I wrote back and said I'll explain them in class. I planned to be with you to explain it, but I did it here on the board. But a lot of these I can go ahead and help you with if you're stuck. So be sure and ask. Don't sit there and get frustrated or say you don't understand it, just close your book. Be sure to ask me so that you can get your work done, okay? If I don't hear from anybody, I'll assume you understand what's going on, and we'll just move right on through, okay? I don't know unless you ask. So I hope that you have a wonderful day, and I will plan on seeing you next week again. Get into contact with me if you need any help. You can even call me, 336-264-5338 if need be. My phone doesn't recognize, if it doesn't recognize the number, it'll shoot it to voicemail, but leave a voicemail and I'll call you back. Okay, you take care, and I'll talk to you next week. Bye-bye.